we will learn that in the plant of morphology, that portion that is the flower, okay, that we will start the flower morphology. All right, this is flower morphology or structure of flower. Okay, so this is we have already learned up to the root, stem, leaves. Those are the vegetative part, and after the vegetative phase, the plant moves to the reproductive phase. And in the reproductive phase, when the plant comes to reproductive phase, then this vegetative birds in the plant that start forming the reproductive bird, that is the flower bird. Okay, flower birds, and this ultimately form flowers. Right. So this actually, this flowers, which is the reproductive structure of the plant, that is actually a uh, modification of a stem, or we can say that is the shoot. It is a shoot modification, very special. And these flowers on the plant or in a branch, they may grow singly, that is the flower may be solitary, okay, solitary, or when in, but in most of the cases the flowers grow in a bunch, in group, large number of flowers grow together. But this growing of large number of flowers on a branch or on a plant, this is in a definite pattern, and this arrangement of the flower on the floral axis, okay, arrangement of flower on the floral axis, this is known as the inflorescence. All right, so we have to learn about the inflorescence, and this inflorescence actually basically two type. One is racemose and another one is cymose. Now, what happened in the racemose and cymose, that in the racemose and cymose, main difference is whether the floral axis ends in a flower, or the floral axis continues growing. When the floral axis continues its growth, that is growth of floral axis continues, and it keep on producing flower laterally. And here in the cymose, the growth of the floral axis stop with the appearance of a single flower. Okay, and that is, say here, this in racemose inflorescence, the main axis continues growing to grow, and the flowers which is born laterally, they are in acropetal succession. What is acropetal succession? That the floral axis keep on growing and it gives out flowers on its lateral side, And in this process, usually what happens, the large flower, those flowers which is appearing first, they are older or they are bigger, and gradually at the tip we get the young flowers. Here you can see one of the uh, photographs. Can you see this flower? This is foxgloves, so that the common garden flower. Okay, here you can see this is one inflorescence, so many flowers together, and on the lower side towards the base, the flowers are already open and large in size, and gradually towards the tip we can see that there are smaller flowers. So at the base, large and older flower, and towards the tip, a small flower and young one. So this is called acropetal succession. Sometimes this succession may be centripetal, as you can see in the sunflower, etc., where the floral axis is very short. In this case, the opening of the flower is from the periphery. From If the floral flower is almost a circular one, the inflorescence, the flower at the periphery that will open first, and gradually it will move towards the center. That is, at the periphery they will open first, and the flower which is at the center, that will open later on. So this is called the racemose inflorescence. In case of mustard, etc., in gulmohar we can see the racemose inflorescence. Here also is a photograph. You can see this photograph, that the flower at the base, they are opening, and in a branch also, that young flowers are towards the tip. This is the racemose. Cymose is just opposite to the racemose. Here the main axis terminate in a single flower. And after that the flower that open, here is one diagrammatic representation of the cymose inflorescence. Here is the main axis. Main axis has been terminated in a single flower. This is in the center. As this main axis has stopped growing, so it has given out the lateral branches, and the lateral branches are below this first flower, and this also has ended into a flower, and then again its growth has stopped, and then it has given the lateral branches, and they are bearing the flower. So every time the growth of the main axis is stopped by appearing of a single flower. So here we can see that, say, if this is that at the tip, the large flower, and at the base is the young flowers. So here this is known as Basi-petal succession. So the flower in case of cymose is basipetal succession or it is centrifugal succession. ऋषभ इधर के ब्लॉक करा जाए. Okay, basipetal or centrifugal succession. ऋषभ এদিকে দেখ তো. ওদেরকে ব্লক করা যায়, এই যে লিখছে ওরা. Okay, so these are the two different types of inflorescence. Now next is, let us see the structure of the flower. In a flower, there are four different type of structure we get. I think you will know that these are the calyx, corolla, androecium, and gynoecium. Calyx, corolla, androecium, and gynoecium. These are the four different structure. Okay, and this in a flower, this is a typical flower. Please, my dear student, can you hear me?
Yes, sir.
Don't write on your computer screen or on the mobile screen. Okay, please don't write. That is coming and disturbing me. All right, you may be disturbed one by another. Whoever is doing that, please stop. So this is the four different structures are there. A flower is known as complete flower. Okay, and another flower is incomplete flower. A flower in which all the four holes, calyx, corolla, androecium, gynoecium, all the four holes are present, the flower is complete. Most of the flower that we see, they are complete flower because flowers are bisexual mostly. In some of the flower, we may get that one of the floral part is absent. Maybe gynoecium is absent from one, or the androecium is absent from a flower, or maybe calyx or corolla is absent. In that case, the flower is known as incomplete flower. Those which are complete flower, in this flower, androecium and gynoecium both are present. This androecium and gynoecium, actually this androecium and gynoecium, they are the male reproductive structure, and androecium is male reproductive structure and gynoecium is female reproductive structure. So in a complete flower, the calyx, corolla, androecium, gynoecium is present. So androecium, gynoecium is present. That flower is bisexual also. Means both the sex organs are present. In case of, say, like cucumber, in case of pumpkin, the flowers are either male or female. Okay, so this is that these flowers are incomplete flower and they are unisexual. So flowers may be bisexual, unisexual, Flower may be bisexual or unisexual. Bisexual flower like mustard, pea, etc. are bisexual, and flower like cucumber, pumpkin, custard, they are unisexual flower. Actually, unisexual flower, they may have androecium. If androecium is there, androecium is also known as stamen, part of the androecium. That is, androecium is made of stamen. So this male flower are also known as staminate flower. In case of pumpkin and cucumber, you will find that there are many flowers which do not bear the fruit. Those are because they are the male flower. And some flower, they bear fruit, they have the gynoecium. So gynoecium containing flowers are female flower, and these female flowers are also known as pistillate flower. Okay, this pistillate flower, because the gynoecium is also known as pistil. All right, so the female flower is known as pistillate flower. Then come to the thing that is called the symmetry of the flower. This is the symmetry of the flower. Flower may be actinomorphic or it is zygomorphic. That is, actinomorphic and zygomorphic. Say, a flower, say if a flower is like this, and this flower can be divided into two equal halves from any of the side. Okay, divided into two similar halves. Say if we divide by this line, then this side 2.5 petals, so this side 2.5 petals. If we divide through this line, then this side also 2.5, here also 2.5. So a flower can be divided into two equal parts through any plane, but that sectioning should pass through the center of the flower. Then the flower has the radial symmetry. Radial symmetry, and the flower with a radial symmetry is known as actinomorphic flower. Okay, so these actinomorphic flowers, they are actually, these are regular flower also. A regular flower, or they have uniformity in their floral structure, that is whatever say like their petals, all the petals are of the same size, same color, similar structure, androecium, gynoecium, okay, particularly calyx and corolla in this case. So they are regular flower and uniform flowers. Uniformity is there. So these flowers are known as actinomorphic. This example of actinomorphic is mustard, then say China rose, potato, datura. These are the actinomorphic flowers. There is zygomorphic flower. Okay. In zygomorphic flower, again, this flower cannot be divided by zygomorphic flowers, or some flowers are having bilateral symmetry. Bilateral symmetry means these flowers are slightly pressed from two sides, and these flowers can be divided into two equal parts, two similar parts or two similar halves through only one plane. Only one plane. Okay. Let us say, particularly in case of pea, if you see the flower of pea, then in the pea flower, one of the petal is very big, two lateral petals are of medium size, and then anterior two petals are very small. And this flower can be divided into two equal halves only through anterior posterior plane, means front to back. That way it can be divided into two equal halves. Say here, this is the posterior, this is anterior. This way we can divide this large petal has been divided into two halves, one medium sized on both sides and one small petals on both sides. But if we cut through this plane, if through this plane, then it is not divided into two similar halves. So this type of flower is the zygomorphic, right? Or it has bilateral symmetry. So bi means two, bilateral symmetry. Zygomorphic. This type of flowers are found mainly in case of leguminous flowers, say like beans, pea. Okay, these flowers are zygomorphic. There are some flowers. Another type is known as asymmetric flowers. These asymmetric flowers are very irregular. They are also known as irregular flower because their floral parts, the petals or the sepals or the androecium, their shape, size, color, etc., that differ, does not match one with the other. So they are of very different type. So there is no uniformity in the parts of the flower. So they are irregular, no regularity. So they are also known as asymmetric flower. This is found in case of canna. Canna, one common garden flower. This has this type of asymmetric condition. Okay. Next thing that one is called merosity. Merosity of flower. You have perhaps from your general experience, you know that in some of the flower, usually most of the flower that you have seen, there are five sepals or five petals are there, maybe five stamens are there. Some has four. Of course, four are very rare, very less, but three or multiple of three or multiple of three. That is three petal or six or nine petals or sepals. Okay, here it is five or multiple of five, four or multiple of four. So how many units are there in different holes of a flower that we describe as its merosity? So based on that, the flowers are, one flower is called trimerous and the flower is called tetramerous and pentamerous. In case of trimerous flower, the floral parts are three or multiple of three. In tetramerous, their floral parts are four or multiple of four. Pentamerous, five or multiple of five. In case of China rose, you will find that there are usually five sepals, five petals. The androecium stamens are many, and that many stamens, they are actually multiple of five, and that is 5x, you can say. And gynoecium also you will find five. So this type of flower that having five, this is the pentamerous. Penta means five. So this tetramerous and pentamerous flowers are characteristic feature of dicotyledonous plant, and trimerous condition is characteristics of monocot plant. Say in case of banana, palms, okay, betel nut, all these you will find this orchids, you will find there is three or multiple of three floral organs are there. So this is merosity. So you have to remember the trimerous, tetramerous and pentamerous flower. Then one thing is that in a flower, that gynoecium, that female reproductive structure that occupies the central portion of the flower. Okay, and other floral parts, androecium, the sepal, that is calyx, corolla, they are around the gynoecium. So flower has a very important character, that which one is above, the gynoecium or the other floral part. So that the relative position of the calyx, corolla and androecium in relation to the gynoecium, or in compared to gynoecium, what is the position of calyx, corolla and androecium? Based on that, flowers are hypogynous, perigynous, epigynous. Now, what is a hypogynous flower? Hypo means below. So, hypogynous its literal meaning is below gynoecium. Okay. So below gynoecium. So hypogynous is the flower where the other floral parts are below the level of the gynoecium, that is below ovary. This is hypogynous. There China rose, brinjal, mustard, these are hypogynous flower. Most of the flower in this group maximum flowers comes. Okay, hypogynous. There is perigynous. Peri means around, the gynoecium. Okay. So a perigynous flower where the other floral parts, they are around the gynoecium. Here around the gynoecium is that the level of the calyx, corolla and androecium is at par with the gynoecium. In this case, usually what happens, this thalamus, thalamus means that is the seat of the flower. The thalamus is usually either it is a concave structure or it is forming more or less a deep cup-like structure. Okay, a cup-like structure. So here what happened, that the ovary is here and the other floral part, the androecium, this corolla, calyx, they are present at the rim of the thalamus. So thalamus here it is little bit concave, maybe it is deeply concave also, forming a cup-like structure. So all these floral parts are coming at equal level, same level, so it is known as perigynous. In the perigynous, this is we find in case of plum, rose, peach. Okay, you have seen the fruit of rose. This fruit of rose is due to that the thalamus is more or less a cup-like structure, and all this carpels, they are present within this cup, and the other floral parts calyx, corolla, and androeciums are at the rim. So this one is perigynous. And here next one is the epigynous. In this case, see, epi means it is above. So above the gynoecium. Gynoecium, we will see that is the position of the ovary. Okay. So above the gynoecium, in this case, what happened? The gynoecium or the ovary is quite below, and the calyx, corolla, androecium is above the level of the gynoecium or above the level of the ovary. So it is called the epigynous. This epigynous flowers are we find in case of guava, cucumber, and the sunflower that florets a small flower in sunflower is a inflorescence. So those flowers are small, so we call it florets. So in sunflower, those florets are all epigynous flower. In this case, have you seen that in case of guava, no? Guava is very common now. Also, whenever you will eat, you will find that very scale-like hard structure at the base, at the tip of the fruit, right? These are actually calyx. You know pomegranate. In the pomegranate, you can see how do you draw the pomegranate, is it? So these are this hard woody sepals, that is the calyx. The fruit is here, fruit is ovary, and the calyx is above the fruit, means above the ovary, above the gynoecium. So these are the epigynous flower. Here we can see, I think, this diagrammatic representation you can see here. You can see this. This flower is hypogynous. Here the thalamus, this portion, this is the thalamus. That is the swollen portion of the stalk, tip portion. This thalamus is convex. So this ovary is situated at the center. So naturally, the level of the ovary is quite above the other floral part. So it is hypogynous. This one, these two diagrams, these two are showing the perigynous flower. Here you can see this is the thalamus. This thalamus has formed a cup-like structure. In this also, here it is a shallow cup, here it is a little bit deep, very low, deep cup is there. And so the ovary, they are situated at the center, and this the calyx, corolla, androecium at the rim of the thalamus. It is there. So they are coming more or less at the same level. Okay. And here one thing, though the thalamus cup has grown up, okay, but this has not fused with the ovary wall. Here is one, this third, this fourth, this diagram. This is the Epigynus flower. Okay. In this case, here is the ovary. All right. Here is the ovary, and this green portion, that this portion around, this is the thalamus. And this thalamus has grown around the ovary. This one is the ovary. Around the ovary, and ovary and the thalamus has fused together and become a single structure. And the calyx, corolla, androecium is at the top. So ovary is quite below the calyx, corolla, androecium. So this is why it is called epigynous, means above the gynoecium. It is around the gynoecium, and this one is below the gynoecium. This Epigynous flowers, now also you can see there are a lot of squash fruits, etc. is growing, or wherever this cucumber, pumpkin is there. In the female flower you will find that flower, at the base of the flower there is a fruit. That fruit means it is the ovary. So ovary below, and the calyx and corolla is above. So this is the next thing. Let us come to the different parts of the flower. Little bit we will learn about the calyx, corolla, and androecium. Calyx, corolla, androecium, and gynoecium. Calyx and corolla, these two are actually not the reproductive part. This androecium and gynoecium actually the reproductive organ. Okay. Calyx, corolla help somehow in the process of reproduction. So this androecium and gynoecium are the main part. So these two are called the essential organ. Essential parts or the essential organ. And calyx and corolla, they are accessory organ. Accessory organ means it is helping in reproduction. This calyx, mainly this calyx protect the flower in its bud condition. So this give protection to the reproductive structure when it is young. Corolla also give protection, because when it is in the bud condition, this androecium, gynoecium is covered by corolla and calyx. But the role of corolla is slightly different, because we see that corolla is mostly colored, and it is attractive. So this attractive corolla, they attract the pollinator. Pollinator means those agency which carry out pollination, which is very important part of the sexual reproduction in plant. So that's why they are helping directly or indirectly for the process. So these two are accessory organ. This, if we see in the calyx, they are made of sepals. Number of sepals, it varies in different plants, in different species. Usually, in most of the cases, you will find it is 5, or say like in trimerous flower, it is 3 or multiple of 3. Okay. So these sepals in the, this is the outermost holds of the flower, and most of the cases these are green in color. So in this way they can carry out photosynthesis also, but main function is giving protection. In some of the flower, some species, the all the sepals, they are united together, partly or fully. So when these sepals are united sepals, this is known as gamosepalous. When it is gamosepalous, say we get it in case of China rose. But in many cases, the sepals are free. Sepals are free from each other, and when they are free from each other, we call them the polypetalous. So sepal calyx can be polypetalous, or it can be sorry, this one, not the petalous, it is sepalous. Polycephalus. Actually, the same term is, same characteristics is used for the corolla also, and the unit of corolla is petal. So when the petals are united, they are called the gamopetalous and polypetalous. In several cases, particularly in case of monocot plant, there is very less difference between sepals and petals. Okay, we cannot differentiate them. So in that case, this, we don't say them calyx or corolla, we tell perianth. So perianth is a term, common term for calyx and corolla. Say in case of orchid flower, in case of canna, okay, and say onion, here the calyx and corolla are not distinct. So they are perianth, and when it is perianth, their unit is called tepal. Okay. Okay, let us see one of the very important characteristics of this calyx and corolla. This is you can see these drawings. Okay, here actually this is called the estivation. Estivation, this is the relative arrangement or the relative position of sepals or petals in flowers. Say for sepals, there are 5 or 3 or 6 or more sepals, how they are arranged. Or petals, there's 5 numbers of petals are there or more number of petals are there, as in case of say rose, so many petals are there. So these petals, they are arranged in a particular fashion, and this in this arrangement they have a relative position, and this position is described by a term called estivation. This is a very important and unique character of all the flowers. This is mainly visible clearly in case of the bud of a flower when it is bud. Here are there are of four main types of estivation is there. First one, this one is the valvate, twisted, imbricate, and vexillary. So this is valvate. This one is twisted. This is imbricate. And the last one, this one is vexillary. Here you can see this in case of velvet, the petals or the sepals are arranged in such a way that no petals or sepal is overlapping each other. They are just meeting by their margin. Okay. Maybe they are fused as in case of gamosepalous or gamopetalous condition, but the position, their relative position is such that they are not overlapping, not covering, or not being covered by any other petals or sepals. This type of condition is the valvate estivation. If we see the next one, here you can see these petals. one margin is covering the next one, and its first margin is covered by the previous petal. Okay, so it is one margin is exposed, it is outside, this is inside. This one is inside, this margin is exposed outside. So inside, one margin is covered, one is exposed. One margin is covered, one exposed. One covered, exposed. So this is called twisted type of. This one you will find in case of China rose. It is very, very clear in China rose petals. This imbricate, in imbricate what happened, this is also more or less like a twisted one, but little different. Here, out of the 5 petals, usually there are 5, and out of the 5 petal, one petal is completely inside, both the margins are covered. Another petal, this one, see here, its both margin are exposed. Okay, it is exposed, and this one fully covered, both margin, and the other 3, this one, and this one, they are in a twisted fashion. Twisted fashion means that one margin is covered, one is exposed. One margin is covered, one exposed, covered, exposed. So here in imbricate, that one petal or sepal is completely inner and one is completely outer. Other 3 are in a twisted condition. So this is imbricate. And then vexillary estivation is very, very special. This one we find in case of pea group of plant. Pea flowers and all the related, all types of beans, okay, in legumes, actually leguminous. This is in member of family Papilionaceae. Okay, here. So in Papilionaceae, what happened? This is a peculiar. This one flower is having bilateral symmetry. In this, there are 5 petals. Out of the 5 petal, one petal is very big, extraordinary large. Okay, and this petal is posterior, means at the back side of the flower, and this is the largest one which cover all other petals. Okay, and this one is known as vexillum or standard. Okay, this is a standard, and there are 2 lateral petals. This one is found only for petals. This vexillary estimation is not found in calyx. So it is only in corolla. So this is the arrangement of the petals. So 2 lateral petals, they are called wing. And in the anterior, there are 2 smallest petal, they are called keel. This type is the estivation, which is known as vexillary estivation. estivation. That's why this stander is also, this large petal is also known as vexillum. Okay, so up to here today, and in the next class, the rest of the portion, we will start means that estivation.
Yes, sir.
Estimation, this of course, okay, in the next class I think I will try that the written is, that is the relative arrangement of the sepals or petals in the whole, relative arrangement. Okay, and there are four main types: valvate, twisted, imbricate, and vexillary. This one is vexillary. Okay. So I will little bit, I will enlarge the